Hi, I'm going to show you several graphs of the chi-squared distribution that I made using some coding a little while ago. And what I'm going to do is run this code, and then it's going to plot chi-squared distributions at different degrees of freedom up to 15 degrees of freedom. Then it's going to do a surface plot of the chi-squared distributions all together. Then it's going to do a contour plot of the surface plot. So I'm going to run it. It's going to take about 30 seconds to run, then I'll explain what you're looking at. And right now it's showing the graphs of the chi-square distribution at different degrees of freedom. That's a surface plot. Then it's working on the contour plot, which takes the longest to graph. Okay. So what we're looking at, here's chi-squared distribution with 1 degree of freedom. The shape chi-squared at 2 degrees of freedom. The x-axis is the x value, the vertical axis is the PDF value. And if you notice, the vertical axis scale keeps on changing. So it's starting at it's at 0.5 right now for 2 degrees of freedom, and it's going to keep decreasing as the degrees of freedom increase, and that's because the mode value decreases as the degrees of freedom increase, or the PDF value at the mode. And the x-axis stays constant. I graphed it through x equals 30 for all of these graphs. Then 3 degrees of freedom, 4 degrees of freedom, etc. If you notice the vertical axis, the max value is decreasing. Here it's 0.16, 6 degrees of freedom is 0.14, etc. The mode, the peak is at the degrees of freedom minus 2. So this is figure 7 corresponds to 7 degrees of freedom. Mode's at 7 minus 2, which is 5. So it's at x equals 5. And keep going. All the way to 15 degrees of freedom. 15 degrees of freedom's sort of taking on the normal distribution shape. I have plotted it to 60 degrees of freedom earlier for fun. Not doing that for this video because it took way too long to create the contour plot. It took about 5 minutes to create the contour plot for it, so I'm not running that for this video. But let's take on normal distribution as degrees of freedom increases. At 60 degrees of freedom, it looked like the normal distribution as far as my eye could tell. Then let's get to the cool stuff. So oh shit. Okay, on the left it's the surface plot. We have, I'm rotating it. Let me rotate the right plot, then I'll explain what you're looking at. Could never figure out how to rotate these graphs the way I wanted them to. Gee. Oh, annoying. After I'm done making this video, I need to learn how to use this rotation tool, because this is just wasting time. It's upside down now. Whatever. So if we look at the left graph, the x-axis, horizontal axis, shows the x values. Vertical axis shows the PDF values. And going into the screen is the different k values. So about where my cursor is, that's at k equals 1, and then it starts high and then decreases. About here is k equals 3 or 4. The chi-square distribution makes that shape. Go down here, k, let me rotate this slightly. So like right here, k equals 10, chi-square distribution makes that nice shape. K equals 15, it takes on sort of a normal distribution shape. Still clearly skewed. You can tell it's skewed just by looking at it usually. But that's the shape. Then on the right graph is a graph of, it's a contour plot of the graph on the left. And the colors on the contour plot don't actually correspond to, I hate this contour plot. I'm going to rerun the code to get a better contour plot. I think I can just run this. Section, I don't know. Anyways, the contour plot's just a contour plot of the surface plot. And the colors, I adjusted the colors because there's a huge peak and then it sort of flattens out a whole lot relative to the peaks. And so the colors were really intense colors on the peak, and then the rest of it was basically just shades of blue. And I didn't like that. Didn't look good. Or it didn't, yeah, it just didn't look good. It actually told probably more useful information than this. But this one looks better. So if I rotate this, so on the lower left of the contour plot, it's red. That means the plot of the PDF takes on a very high value. And then if we look at the PDF or the plot on the left, it decreases the max values along this 45-degree angled line. Then here, the hottest spot's always along that line, which is the line where the mode is at different chi-squared values. And on the graph on the right, the degrees of freedom's on the horizontal axis and the x values on the vertical axis. And then we can look in the mode by looking at the contour plot is still at k minus 2. And that's all I did in my spare time today.